Hi, I'm Jeff Fox, and welcome to Slooh. We're going to be talking about comets this afternoon, and we're going to be talking about it because we love the sky at Slooh. In fact, you're looking at an animation that shows you one of our two Slooh observatory locations. We are a community observatory. Our members set the agenda every night on where our 3 telescopes in 2 observatories on 2 continents point. You're looking at our telescopes on the Canary Islands, just off the coast of Africa in the Atlantic. A phenomenal place to look at the sky. And that's what we will be doing tonight. I'm joined by Bob Berman, our Slooh astronomer and author of a multitude of books on the nighttime sky, and also, and actually, I should say, Bob, and also the daytime sky, because you got the sun covered also, and also by Paul Cox, who is our Slooh observatory manager, and who takes care of all the nuts and bolts to make sure that we're always operating. So, gentlemen, we're going to talk about comets tonight. These are sort of the orphans of the nighttime sky, aren't they, Bob?
Well, yes, even though they affect us greatly and may be responsible for the fact that we have oceans, they're not planets, they're not moons. They become well known only when a great one comes by every 15 years or so. Nonetheless, Slooh members watch fabulous comets almost all the time.
Now, how many? If I were to look at a telescope like the Slooh telescope or any backyard telescope, can I always see comets? Are there always comets available?
Paul?
Well, the quick answer is yes, but it's a question of how visible they are. And what we're looking at now, actually, Jeff, is a whole series of comets that Slooh members have imaged with the Slooh telescopes. And you can see they really vary. Some of them are large and very, very bright with very distinctive tails. But other times, we've got a couple that we're going to show a little bit later, where you have to blink between two images before you can actually make out the tiny, tiny dot. But the live one we're showing tonight, Jeff, that is very visible and is showing up beautifully in the telescopes.
Well, tell me about this comet we're looking at tonight, Paul. Who discovered it?
Well,
and is it visible?
Well, it's Comet Catalina. It's C 2012 UQ4, discovered by the Catalina Sky Survey. And it's a really fascinating object, this one, Jeff. It was discovered on the 23rd of October 2013. You can get that from its name. But when it was originally discovered, they thought it was an asteroid. So it was actually, first of all, named 2013 UQ4. And then suddenly, I think it was in May. Yeah, it was in May. Suddenly, it started to display this very distinctive tail. And some of the older images that we're looking at now, in fact, here we go. Here's one of the first images that Slooh members took of it when it just started displaying this wonderful tail. So, Bob, what's that old quote about comets are like cats?
Yes, that's from our friend Levy, who's an old comet hunter. Comets are the only objects remaining in the universe that get to bear the name of their discoverer. So if Levy finds a comet, or Robert McNaught, it'll be Comet McNaught. And if you find a new galaxy, well, too bad. It's still going to be named VX123 ABC. So that's one of the things about the appeal. But you cannot predict what they're going to do, and that's what Paul is saying. We can always predict where they will be, but not exactly how they'll brighten and how the main body of the comet, which is essentially just ice with dust embedded within, how it will sublimate, how much gas and will be released, how much water will be released in the form of vapor, and therefore what kind of a tail it will be. And it's this unpredictability which is part of the fun.
Bob,
so
on
what
that
is
one,
the difference between? I'm sorry. Go ahead, Paul.
No, I was just going to say that, we've said to people, look, there's always comets in the sky that you can look at. We're looking at one here, actually. This is a very recent image by one of the Slooh members, and this is Helen Roman Alu 1, quite an indistinct comet, but that one's going to get a little bit better later. Bob, you'll be able to pronounce that better. But we've said comets are always available to look at in the sky. But where are they from? Where's this constant stream of comets coming that we observe every night?
Good question. Since comets lose some of their material every time they pass near the sun, there's a loss, and so they must be refreshed, replenished, and they are. There are two repositories. The Kuiper Belt has icy bodies that, if anyone is nudged, perhaps by a fellow Kuiper Belt object, it can be knocked inward to our neck of the woods. And then there's the Oort cloud, which is a much larger and more distant repository of icy bodies, and that can send comets our way. So fortunately, there's enough of a reservoir of them that we never seem to run out.
I mean,
Can I go
we're
back
talking
for just a second? I just want to go. I'm sorry, Paul, but I just want to go back for a second. You talked about the fact that this comet was originally thought to be an asteroid.
Yes, that's correct.
What's the difference between a comet and an asteroid? Because they seem to have similar orbits. They show up from similar locations. Is the only difference a tail?
No, no, actually not, because asteroids generally are remnants of a planet that never formed when there were planetesimals in the early solar system. Most of them are between the orbits of Mars and Jupiter. Most asteroids orbit counterclockwise around the sun, and most are reasonably within the flat plane of the solar system. But comets come from any direction, move in any angle, and therefore that shows that they are more likely to be Oort cloud members. That is this spherical surrounding cloud around the solar system. And so very different orbits and very different compositions, Jeff. The asteroids are generally rocky or metallic, and the comets are mostly ice. They're mostly water ice.
And you said before that this may be how we got water on Earth.
Sure. How did we get our oceans? It's very unusual to have oxygen to begin with, and almost half of our planet is pure oxygen. And so where did this H2O, all this water come from? And there's a line of thought that it was comets coming in, especially in the early Wild West years of the solar system, when there were a lot more bombardments than there are now. That all the comets coming in burn up in our atmosphere, but the water is captured gravitationally and eventually produced enough to give us our oceans.
Wow.
Oh,
But
can I
the
just
comet.
interrupt here? Can I just interrupt here? This image is from one of the Slooh members. I'm just going to call up his name actually, if I can find that. It's Hongsun Moon, Yoon, sorry. And which one is this? This is. Oh, we should have a caption on the screen for this. It's Bob. Do you recognise this one? It was a couple of months ago.
No,
Is
but
this
I
Pan
love the green
Stars?
color. Oh, yes, it looks like pan stars, and whenever we see this green, it's often from cyanogen. Now, this is a combination of cyanide, you know, with some oxygen and other stuff mixed in, and this is the reason why when Comet Halley was predicted to cross our orbit in the year 1910, many thought it would be the end of the world because the cyanogen from comets, which was known even back then, was thought to poison our atmosphere, and that comet pills were being sold at that time, and comets were believed to be deadly. But look how pretty this is as we see the glow, this green glow. That's another thing you'll never see from an asteroid, another visual difference. Also, asteroids, they're sturdy stuff. The rocks and metals, they're not going to fall apart just because they come near Earth or come near the sun. But comets, they're fragile, and they have two tails. In this image that Paul is showing us now, we see one of the two tails. There can be a plasma, sometimes called an ion tail, which is atoms that are being ionized by their passage near the sun. And then there is a dust tail because all that embedded dusty material that's released when the ices sublimate. I'd love to say the ices melt when the comets get near the sun, but you can't
No,
have
no, no,
water.
no.
You can't melt. You can't melt in the vacuum of space. So all you do is turn directly from solid to vapor, and that releases the dust. So we get up to two tails. Actually, you have multiple tails because you can have more than one dust tail and more than one ion tail. So very lovely.
Then I have a question. If these are blown by the solar wind, they go basically in the opposite direction from the sun. Why are those two tails moving in slightly opposite or slightly different angles?
Oh, that's a great question, and absolutely true. Just like a windsock at an airport, the solar wind, that is a high stream, a high speed bunch of material, broken atom fragments that are blown away from the sun, typically 200, 300, 400 miles per second. They will blow the material from the comet backwards. But to answer Jeff's question, one, the ion tail and the plasma tail will go in a different direction from the dust tail because one shows where the comet was in its orbit, and the other shows the direction directly away from the sun from the comet. Since the comet has a loopy elliptical orbit or parabolic orbit, I mean elliptical orbit in the case of Comet Halley, parabolic or even hyperbolic in the case of long period comets, the two will not coincide.
Gents,
So
we
we've been
saw
looking.
that that lovely image that we saw from Hongsun Yoon was actually Comet X1 Linear. But I wanted to interject here because this image that we're seeing, this animation, is the demonstration that not all comets look so beautiful. And the only way we can make out this particular comet is if we take a series of images and animate them. And you can just see at the center of the screen a tiny black dot moving between the two stars. And that's the comet in this particular case. And this one is C2013 US10, another Catalina Sky Survey discovery.
Yes, fascinating. And notice the different names, the disparate names. Some of the names sound like license plate numbers, and some of them have a ring to them. Like, people will always call it Halley's Comet, thanks to that pudgy actor singer from the early 50s, Bill Haley, and his comets. The real name was Halley. Some say Hawley, Comet Hawley, named after Edmund Halley. But there you go. Some names, Paul earlier said, Bob, you'll know the name, how to pronounce this name, but only the discoverer, only a person who owns the surname is an expert on its pronunciation. So sometimes we're stuck with, like in the mid-90s, we had Comet Yakutaki one year and Comet Hale-Bopp the next year. Now, we were all so happy with Hale-Bopp because here were single-syllable names, co-discoverers. You couldn't mispronounce Hale, and you could not mispronounce Bopp. Tom Bopp, I know that fellow from Arizona who just happened to discover the largest, brightest comet of the century, of the 20th century. But the year before was a Japanese discoverer, Yakutaki. What can you do? You can only ask these guys, how do you pronounce your name? They're the experts.
All I remember about Yakutaki is the immense pair of binoculars that he used to find it. That to me was fascinating, how comets are looked for by people like him.
Right, right. I used that 1995 and 1996, that pair of comets, to be able to tell where a person lives. If somebody says, I remember Hale-Bopp, that was the best comet ever, it means they lived in the suburbs or in a city. But if somebody says, Yakutaki, that was the best comet I ever saw, that's the giveaway that they were out in the country, because that was the superior comet, but only to people who had dark enough skies to be able to see this freaking 90-degree tail that spanned half the sky. But you couldn't see it. It was a fifth magnitude tail, so there was no trace of that tail from suburbs or from the cities. From suburbs or the cities, Hale-Bopp was the better comet because its little 10-degree tail, it actually grew to 20 degrees at one point. That's pretty darn good. It was so bright that for the better part of a year, it could be seen even through the lights of cities. What a comet.
So, Paul, we're looking at comets that can be seen mostly from the northern hemisphere, but we also have an observatory in Chile, and that's in the southern hemisphere. And it's my understanding that our members are actually looking at other comets there that they couldn't see from north of the equator.
Absolutely. We've got a sky chart up at the moment, and this shows the sky tonight under or over our Chile observatory, and we can see there that the comet Siding Springs, this is 2013 A1 Siding Spring, is only visible from there. It's below the horizon from the Canary Islands Observatory, but this particular comet is one that is going to be hitting the news in a big way, Jeff, and we're going to be following this for the remainder of the year. Bob, you can probably tell us about Siding Springs' close encounter that it's going to have in October?
Yes, I don't know the details of it yet. I was at Siding Spring last fall and had the pleasure of hanging out with Rob McNaught, who told me that he was about to lose his job. Can you imagine that? The person who has discovered more comets than anyone in the world, including Edmund Halley, including Levy, and they were defunding it, but that was Siding Spring. So
and
yeah,
he discovered this one. He discovered this one, Bob. C2013 A1 Siding Springs is one of Robert McNaught's discoveries from that observatory using a half-meter telescope. We use a half-meter telescope in the Canary Islands Observatory. But this comet is going to have an incredibly close encounter with Mars,
With Mars.
on the 19th of October. It's going to be 10 times closer to Mars than any comet, any observed comet, has ever been to the Earth. Isn't that amazing, Bob? Because we were talking about the impact that comets can have on Earth. And this
we'll
shows that they get that close.
We are going to be watching that at Slooh, aren't we?
Well, we are going to be monitoring this one. As we say, we're going to be putting on probably monthly shows all the way up to that close encounter, as long as we can see it. But in the meantime, Slooh members are actually imaging this every morning. It's a pre-dawn object from the Chile Observatory every morning.
Beautiful. And Mars, those people... Just go ahead.
Let's pause the conversation here for a minute. We're going to talk about the Slooh Observatory, the observatories, I should say, and what our members can do from there. We'll do that coming back right after this message. Eric, are we back? So, hold on. Before we start back up again, though, this is just practice. So. All right, so for those of you who don't know, Slooh is the community observatory. We have basically solved many of the worst problems that astronomers had by leveraging the internet. You live in an area that's too bright, you live in an area that has too many clouds, don't have room to put in a really nice telescope, or have the kind of investment that you would have to make. Use ours. That's what the Slooh observatories are all about. Paul, you're the observatory director. Give me an idea of what kind of hardware that we have that our members are using with Slooh.
Okay, well, take the Canary Islands Observatory as an example. First of all, it's at this high-altitude site. You're seeing some of the other domes at that particular site on top of a volcano. So the conditions, as you say, Jeff, are absolutely perfect. But the telescopes we have, there's a whole range of them, and they're for different purposes. So we saw a minute ago, and we'll see another of our live images, actually, of this beautiful comet tonight. That's taken using our half-meter telescope. Now, anybody who knows anything about telescopes knows that that is a huge piece of glass. It's a very, very large. And if you wanted to buy one, yeah, you can do for about $35,000. That's what's generating this live image. Now, we have another dome in the Canary Islands Observatory, and that has a smaller telescope, 14 inches in diameter, but that is what we call our planetary telescope, and that takes it has a far smaller field of view. It has a longer focal length. Fantastic to view planets up close, Jeff. And the Canary Islands Observatory has the same as that, but down in the southern hemisphere.
So the Chilean observatory is below the equator, so you really get a whole different look at the sky than you would from North America or from Europe.
We've got full sky coverage. There is nothing in the sky that we cannot view from the observatories at one time of the year or another.
And by the way, you see on your screen, we're actually now having an introductory membership offer. If you'd like to try out Slooh and see if we fit you, give it a shot. 3 months for only $29.95, so you're saving 60% on our normal membership. More than just having the access to the telescopes, by the way, you also have access to our clubhouse, where our members, who are all into astronomy, are very active, and we have some questions from them tonight, so let's get to some of those, and Paul and Bob, you just chime in when you find a question that I'm about to make up that you like, okay?
Well,
sounds good.
Okay.
But before you go, I have to give a correction. Earlier I mentioned that cyanogen that we saw glowing from a Slooh member picture of the comet was a combination, I think I said cyanide and oxygen. That was ridiculous. Cyanogen is a combination of carbon and nitrogen. It's C2N2. No oxygen in cyanogen. Please proceed.
Bob knew that all the time. He was just testing Jeff and I. We missed it. We're sorry, Bob.
Now I feel like such a fool. I'm going to make up some sort of question here, but tell me about Paul, the images that our members get back from the telescope, because here I am sitting in front of my computer monitor, and I have a good computer monitor, but that's not really high resolution. I mean, are these scientifically usable images that come off our scopes?
Absolutely, Jeff. And the image that we're looking at the moment is a live image from the half-meter telescope. So this is what members get to see. Now, the images start in grayscale. So they see them as black and white when they start off, because it takes a long time to capture all of those photons from objects, which we actually captured an object 2 nights ago, 9 billion light years away, would you believe it? Took those photons to get to the camera, and it slowly builds up the color. So every 5 or 10 minutes, everybody can watch their own missions that they set up and control, or other members. You can watch what everybody's doing, and you can not only collect, you can snap a picture of anything live you see. You can snap any of these. It goes into your own private collection, Jeff. But if you're of a scientific orientation and you want to do some science with these images, you can also elect to have what's called the FITS data. And that's just basically a scientific format which enables you to perform astrometry and photometry on those images.
And do our members make those really great false color images that we often see from NASA of distant galaxies and parts of the sky that just are, biblical in proportion, if you will?
I would say sometimes more by accident than by desire, false color. Because what we do is every time a member controls the telescope, it takes a series of images, some through what's called a luminance filter, which is basically a clear filter, but then through red, green, and blue filters. We've got patented technology that automatically combines that to generate the live color images that members see, but they can create their own. And when they combine those red, green, and blue, they can kind of assign any color to those. And there is what's called the Hubble palette, and you can apply that, reverse some of the colors, and come up with those extraordinarily funky and quite hippie-looking LSD-inspired images.
Well, guys, it was fascinating being with you this afternoon. I know that we have a show coming up on Sunday. Uh, this is an amazing show because this is the 45th anniversary of Apollo 11 and the first humans to be on the moon. Bob, have you already done an interview for this show that's going to be airing on Sunday?
Yes. We've had a nice talk, and we're going to show you that interview with Duncan Kopp, award-winning documentary maker who's interviewed many of the astronauts. And I think what people will find very fun about that is we have a whole storehouse of little known tidbits and perilous things that happened and behind the scenes stories of that first landing on the moon, and we're going to reveal them all during our Apollo 11 extravaganza on the 45th anniversary coming up this Sunday night.
Yeah, all right. Well, we'll see you all on Sunday. On behalf of our astronomer, Bob Berman in the middle and down at the bottom, Paul Cox, our observatory director. I'm Jeff Fox. Thank you for joining us. Make sure you check out our website. It's Slooh, SLOOH.com, and find out what Slooh is all about. Thanks for joining us. Bye-bye, everybody.